This video is the differentiation solutions for our calculus revision. Our first question is first principles, so we need to know what the rule is to be able to do this. As always, it's a good plan to write the rule down before you begin to use it. For this particular question, I'm going to do it bit by bit, so I'm going to first of all find f of x plus h. This just requires me to replace the x's in f of x with x plus h instead. I'll expand this and tidy it up a little bit. Feel free to use a couple of extra lines to do that if necessary. Next, I'll take f of x away from this. Now, what's nice to know about this process is that when you actually take f of x away from f of x plus h, all the components of f of x are going to cancel out of f of x plus h. So really what I'm doing is I'm trying to spot where they are. So I've got my 3x squared there, I've got my minus 2x, it's there, I've got the plus 1 there at the end, and essentially they're all going to get knocked out. So I'm left with 6xh plus 3h squared minus 2h. And now what I want to do is divide this by h. So you can see here I've just divided by h on both sides. And in order to cancel out the h, what I can do is I can factorise h out of this top line. Once I have that done, then those h's can just get removed. Now I'm ready to use all the elements of the formula, so I'm going to include the limit as h goes to 0 at the start. So I'm applying that limit as h goes to 0 to 6x plus 3h minus 2. All that basically means is that any remaining h's get turned into zeros. And since 3 zeros is 0, this effectively eliminates the 3h term. This leaves me with an answer of 6x minus 2. So I'll just conclude by saying that f dash x equals 6x minus 2. Now it's also quite nice with these questions that you can visually check it pretty easily, just using your quick method of differentiation. Bring down your power and multiply 6x, drop your x minus 2, constant disappears, and that aligns with what we have as our answer here. On we go to question 2, part 1. We're just asked to differentiate. There's no need to go through this whole process, only if it just says first principles in the question. So this time we're using the quick way, but we just have to double check first of all if it's possible to proceed. So I notice here I've got x squared in the denominator of this term, so I just need to sort that out before I can begin to differentiate. So I'm writing that last term as minus 1x to the power of minus 2, and now I can find dy dx. I've differentiated here. Notice that I've brought powers in front, multiplied and reduced the powers by 1. My constant term has been dropped. And just watch out that when you're reducing minus 2, you bring it down to minus 3. Now the question didn't ask for a particular format, so actually this is fine for the answer. But if it did require you to write this last term in a different format, you could also give your answer in this format. Okay, on to part 2. We notice that we've got multiplication of brackets. That's a good indication that it's going to be the product rule. So I'll call the two brackets u and v, and I'll have to differentiate those. So for the first expression there, cos x plus e to the x, the cos x will differentiate to give minus sine x, and then the e to the x, when we differentiate e to the x, it just stays exactly as it is. So we've got plus e to the x on the end. Watch out in the second one because I've got a power, so I'll have to take that into account. So I'm differentiating v to get dv dx. The constant's going to get dropped. I have to think of my steps for trigonometric differentiation here. So power, ratio, angle for trigonometry. So first of all, the power, so that power of 2 needs to be differentiated. So I just bring it out in front like I would with normal differentiation. Then I have to differentiate the ratio, so that's the sine part of it. And sine differentiates to give cos. And then finally, I need to differentiate the angle. Well, it's just x this time, so it'll differentiate to give 1. And I can tidy that up slightly. Minus 2 sine x cos x. So I want to use product rule. Again, no harm to note the rule before you begin to fill it in. And you might find those arrows helpful as well to remember what goes with what. So in this case, I've got u dv dx plus v du dx. And there's no requirement in the question to tidy it up. So you don't strictly have to. And in this case, I'm just going to leave it as is. Okay, question 3, part 1. Find the second derivative of y. So that means find the first derivative, differentiate once, and then do that again. Here we notice that we don't have brackets, but we do have multiplication. The x term is multiplying by the exponential term. So we'll have to do our u and our v again. These are pretty simple terms to differentiate. Du dx is going to be 1. And for dv dx, now we have to differentiate the power on the exponential term and put that in front and then leave the rest of the thing as it is. So dv dx is 2e to the 2x. Again, you can stick in the arrows if that helps. And then we're going to find dy dx. So again, it's just this rule from up here, the product rule. And I end up with dy dx being 2x e to the 2x plus e to the 2x. And then I want to go and do it again. I want to get the second derivative. So let's have a look at what's going on then. So we've got 2x e to the 2x that we have to differentiate, and we have to differentiate e to the 2x. The second guy is really straightforward. We can actually use what we've done previously in this question to make this first part a bit more straightforward also, if we like, because look, we've just differentiated x e to the 2x. This is just 2x e to the 2x. So this is twice what the first guy was. So actually what I can do is I can say, I know that when I differentiate this expression, I get this expression. If I differentiate this expression, which has a 2 out in front of it, I'll get double this. So that's that first term differentiated, and then e to the 2x is really easy. Like we saw a moment ago, it's just 2e to the 2x. I can tidy up here a little bit if I like, just by multiplying out, and then these two terms can add together. And there I have my tidied final answer. But actually, when we were asked for the second derivative, once we get it, because they haven't asked us to tidy up, we could actually stop there. Now, you might have gone about this a slightly different way. That's fine, but you should end up in the same place at the end. It's handy to spot shortcuts like that, though. It can make life much easier. Okay, so second derivatives again in 3-part 2. So I've got two terms here. I've got a trig guy, and I've also got something that I need to sort out in terms of its power before I can begin. So I've just sorted out that 1 over x initially, and then I'm going to have to use my power ratio angle rule down here with this guy. So let's go ahead and get our first derivative. Notice, by the way, I've got slightly different notation this time around. I had y over here, dy dx, and d2y over dx2, and over here I've got f of x and then f dash x, okay? So looking at my first term then, so power, so the 3 is going to go out in front. Differentiate the ratio, I'll leave the power out of it now completely, and then differentiate the angle. So that's that first trig term sorted out, and now I'm going to go on to the minus 1x to the minus 1, and that gives me 1x to the minus 2. I'm going to tidy that up a little bit, and there I go. So now I'm not finished yet because that's just the first derivative. I also have to find the second derivative. I've got a bit of product rule going on here again now, so my rule's written up here from before. So I've noted my u and my v. I need to find my du dx and dv dx. A good bit going on here, and in the first one I've got to do my p or at again, power ratio angle. And then for the second one, it's a little bit less because I don't have a power, so just ratio and angle. The arrows again can be a bit of a visual aid there for me. And now let's assemble the second derivative. So we have to say u dv dx plus v du dx, and then don't forget this guy at the end. So there's a couple of elements there. So u dv dx plus v du dx. I've tidied that up a little bit as I went along. And then my last term, the algebraic term. I'm just going to tidy this up slightly for my last line, although you're not strictly required to because I didn't ask for it in a particular format. So as long as you've got your f dash dash x and all the components of that written out, you're doing fine. Our second page has 3 application questions. First of all, we're looking at inverse trig differentiation. First thing I have to do is give it a name. I'm going to call it y and bring the sign across. I'm going to write that 3x plus 1 as a fraction. I'm just putting it over 1, and then I'll draw my triangle. I need to find the missing side of the triangle using Pythagoras. I'm going to call it a because it's adjacent to y. And when I manipulate this to get a by itself, I should get this result. So now, at this stage, I've got a, so I've got all the sides of the triangle. I'm going to use that to write down cos y. And that's just adjacent over hypotenuse. So I can just write cos y as the square root of minus 9x squared minus 6x. And I want to differentiate now the expression that I started off with. So I'm using implicit differentiation here, so just watch out for those dy dx's. I've got my trig differentiation, of course, so I've got to do power ratio angle, no power here, ratio, yes. And of course, sine differentiates to give you cos. That's why I've got the cos y written down up here. When I differentiate the angle y, I get dy dx. And then 3x plus 1 will just give me 3. So I'll rearrange this guy now to get dy dx by itself. I'm nearly there. So I've brought the cos y across, and of course I have cos y figured out from a minute ago. You could have left this little section here until this point if you'd wanted to and realised that you needed the cos y. But in any case, now that's going to get substituted in there. And there's my answer for dy dx, 3 over root minus 9x squared minus 6x. Okay, on to question 5. We're looking at max and min turning points. The first thing that I notice here is that the function is given to me in an unexpanded form, so I want to start by multiplying that out. And once I've that done, then it'll make it much easier for me to differentiate. So I've just skipped there to the expanded version, so I'm sure you can multiply that out yourselves. You should end up with x cubed minus 12x squared plus 36x. No surprise there, by the way, that it's an x cubed, because I could see that it's a cubic function. And also no surprise that it's got no constant term, or constant is 0, because you can see that its y-intercept is at 0 at the origin. So now we go on to finding our turning points, and of course that just means differentiate and let it equal to 0. If you like, you can divide this across by 3, although you don't have to, in order to solve for x. And then we can factorise and finally solve for x. Of course, I need the full points, so I'm going to have to substitute those in, and I'm putting them back into the original function. So I'll put in 6 and I get 0, so that means I've got a point 60, and I fill the 2 in, I get 32, so that point is 232. So now I've got all the points, but I have to just check now or determine whether each is a max or min, so I'll use my second derivative for that. Just watch out when getting second derivative, take it from the original first derivative, don't take it from the divided version. So this is getting differentiated for the second derivative. And then I'll sub each of my x values into that also. Subbing in 6 first, I get a result of plus 12. It's the plus is the important part here. It tells me that I've got a minimum. Subbing in the 2, I get minus 12. Again, it's the minus is the important factor in this, telling me I have a maximum point. So I'm just going to go back down to these points now and then write in which one's which. And that's question 5 completed. And finally, we've got question 6, which is a related rates of change question. Let's have a look through it. The area of a circle is increasing at a constant rate of 1.5 centimeters squared per second. The minute we see that anything's doing anything at a rate, whether it's increasing or decreasing, the rate indicates we're probably going to be using dt, and it's the area that's changing. So that's going to be dA dt. So area is changing over time. So that's the first thing that I should note. Now the question's asking me to find 3 significant figures, the rate, so there's that word rate again, at which the radius is increasing. So the question's asking me to find dr dt. Now, so I'm going to have to use the information that I know in combination with something else to get dr dt. So I've got dA dt, and now I have to have a think, okay, I want dr dt, so I want a dt on the bottom, so that's fine. I don't want a dA, so I want to get rid of that. I'll put a dA on the bottom to get rid of that, and then I want a dr on top, so that has to go in there. Okay, so now my checklist, I have dA dt, there we go from the question. dr dA I have to find. So I have to first of all start by getting an equation that has a and r in it. Well, I'm dealing with a circle, so area formula. I can differentiate this to get dA dr. It's not quite what I want though, I want dr dA, so I have to flip this guy over. So I can just flip this over, I'll put it over 1 first. And then I'll just flip it for the dr dA that I want. So I'm going to put those two now into that formula for dr dt. I can tidy that up as 3 over 4 pi r if I like, or I can just leave it exactly as it is. Both are fine. But I want to get an answer to 3 significant figures, so I want a number answer, so this needs to be a number. So I have to fill something in, and the obvious thing that I can fill in is the r, because obviously pi is just a set value. So how am I going to find the r? Well, I'm told the area of the circle is 2 centimeters squared, so I can actually figure out my radius from that. I'm just going to use the area formula again. I know the area is 2, I can figure out r. So I'll work to get the r by itself, and I'm fine to leave this in surd form, by the way. So r equals to the root of 2 over pi, so I can just substitute that in now for the r down here. It wants it as a decimal, so I'm going to go to my calculator and type this in to get an answer, remembering to give 3 significant figures. Ideally, I'd like to include units. Notice how it's been centimeters and seconds the whole way through this. And looking at what I'm finding, dr dt, well, radius is measured in centimeters and time is measured in seconds. So my unit will be centimeters per second.